welcome to this particular module, and this is again a experimental component of our lecture or theory class. The today's module will be focusing on how to use 3D printing technique. Now 3D printing, as you know, has evolved several tens of folds from last few years, and now it has been people are exploring the the beauty of 3D printing into several different applications, right from automotive to medical devices. What kind of materials you can use, and then how the fabrication of this particular casing can be done using 3D printing module. I am just giving an example. Okay. There are several kind of 3D printers, including metal 3D printers. We will be not talking about metal 3D printers, we will talking about two small modules that we have in the laboratory. I will request Saeed to discuss about this 3D printer and take it over. If you have any questions, again you are free to ask me. Let me again remind you, there would be a certain live sessions as a part of this particular program. Apart from live sessions, there is a forum in which you can ask any technical questions. All right. So feel free to use the forum in the best possible manner. You take care, and I will hand over the lab to Saeed. Bye.
I will be explaining about 3D printing. In the 3D printing, there is CAD software, 3D modeling with Autodesk Inventor, 3D printer technologies, what all different type of 3D printers are available, and then 3D printing material, 3D printing and a printed part. I will show you how to 3D print, how 3D printing will look like, and a 3D printed part, and remote 3D printing and remote controlling of 3D printer. In the last session, I explained about sign up for a student account in Autodesk Inventor, downloading 3D modeling using CAD software. Here in the video I use Autodesk Inventor for that, and basics of modeling, basics of Autodesk Inventor, how to use different options to create objects, and I explained most of the things using an example of an enclosure for switch, and I explained about how to make an enclosure for switch. So today I will be explaining about 3D printer types. So I will explain about 5 different type of 3D printers, or 5 different type of 3D printing technologies, and there are more than 5 different types, but thus all different types can be similar to the 5 numbers I am explaining here. The first type I am going to explain is fused deposition modeling 3D printer. So the material will be stored as a filament, and the filament comes in a roll form. So the 3D printer will take the filament from the roll and heat it and will deposit on a surface. In that fashion, here you can see there are 2 photos. A cup is being made. So here you can see a build material spool. There is the spool is where 3D printer filament is stored, and next here you can see a support material spool, and while printing something or while making a 3D printable object, the 3D printer may require some support. Suppose here we are making a cup, so the cup handle is something which is coming out of the main body. So while printing, the 3D printer may require some support structure to support the handle being made. So that's why this 3D printer is using a support material. And then here a liquefier head it is shown. the liquefier head means it will melt the material, both build material and the support material, and deposit on a frame which will move in Z axis. And it is the most cost efficient way of producing custom thermoplastic and parts for prototypes. Of course, that is for low volume. And the FDM 3D printing has the lowest dimensional accuracy and resolution compared to other 3D printing technologies. But one more thing is FDM 3D printer is in industrial grade FDM 3D printer and home use or personal use 3D printers for FDM 3D printers. Thus, the accuracy and the dimensional accuracy may differ, but as we stack different technologies, this is one of the FDM 3D printer will give only lower dimensional accuracies. Suppose we are printing a document in an A4 sheet. So, this is the A4 sheet and the printer will print line by line. Suppose line by line it will print. Suppose this is a big letter A. The letter A will be like this. This is a 2-dimensional printing, but in 3-dimensional printing there will be a nozzle, there will be a heater here, and the material will come through the heater, and the material will be melted from here and it will be deposited through the nozzle, and it is collected on a plate that is also called build plate. So, the build place is here, and suppose this is x axis, and this is y axis, and the axis towards you is z axis. So, the 3D printing nozzle will go somewhere here, and before doing 3D printing we will do some processes to give the file to the 3D printer, so that 3D printer will know what object we have to print and how to print the object. So, the object will be cut into different layers, and the nozzle will deposit material layer by layer. Suppose we want to make a 3-dimensional A. Here I just showed a letter A, and we want to make a 3-dimensional letter. So, the nozzle will go to the build plate and it will start depositing material, and the first layer will be like this, and it will fill with the material. The nozzle will move in x and y axis, deposit material like this, and then the build plate will move far away from the nozzle, or the nozzle will move far away from the build plate. Both are possible in FDM 3D printers. I will show both type of FDM 3D printers in a next video. Here the build plate will move away from the nozzle, and then again it will deposit the same material. I will show in a different color. Again it will deposit material on top of the first layer. It will be like this. So if you are looking from the top, you will only see this orange color, that is we have 2 layers of material. Similarly, the nozzle will deposit multiple layers to make a 3-dimensional object. Here I explain it as a with an example of 3-dimensional letter A. Next is stereolithography. Here there are some difference from the previous FDM 3D printer. This will be here the material will be a liquid resin. The specialty of the resin is when a UV light is shown to the liquid, it will solidifies. Previously in FDM 3D printers, there will be solid material, solid plastic material that will be heated for making it easier for deposition of material. Here in stereolithography, the material will be liquid, and as you can see in the picture, there will be a laser source and a laser scanner system, and then the laser beam is shown to the liquid resin. Here the liquid resin is there, and layers of the U shape is the layers of solidified resins. In the right side, after the completion of object, you can see the finished part. Here there is a platform piston. The platform piston will be in the top side when the printing is started. Once the first layer is finished, the piston will move downside, and the next layer will be in progress. Here the objects are created by selectively curing the polymer resin layer by layer using a laser beam. One of the advantage of this SLA 3D printing is its high accuracy and smooth surface finish. The high accuracy and smooth surface finish comes at a cost. Compared to FDM 3D printers, the cost of the material, the liquid resin is very high, and compared to FDM 3D printers, the SLA 3D printer, most of the prints will require post processing stage. In FDM 3D printing, if we are not using some support material, we can almost print a finalized part, and most probably you will not require any post processing. But here in SLA stereolithography, you will require a post processing stage. Next is selective laser sintering, SLS. In short, it is called SLS. The material comes in powder form, so it will be in solid powder form. In the SLA stereolithography, we discussed just before, the material is coming in liquid form. Here in SLS, the material is coming in powder form. Here in the image, in the picture, you can see there are there are two reservoirs. One there is only one there is one reservoir, and next is the printing volume. Initially the piston on the reservoir will be at the bottom, and the full material will be stored in the reservoir, and the in the build volume, the fabrication will be at the top side, and the roller here you can see the roller will move from left side to the right side. Definite quantity of powder is transferred from the reservoir to the build volume, and the thickness of the powder delivered to the build volume is controlled, and the roller will move from left side to right side, and again it will come back to the initial position, such that the uniformity of the layer delivered to the build volume is consistent. And then a laser source is there, and a laser scanner system that will direct laser beam to the XY axis which are required. And in this also here the laser scanner and laser pointing system are similar to the SLA 3D printing method, but the only difference is instead of a liquid resin, here we are using a powder material. So here the material from reservoir is transferred to the build volume, then the laser is pointed and the material is heated, and the material which are exposed to the laser will be sintered, and the material will adhere together. In this method also the 3D printing is happening by solidifying the powder layer by layer, and one of the main advantage of SLS technology is it offers very high design freedom and high accuracy, and produce parts with good and consistent mechanical properties compared to the previously discussed FDM or SLA. Here one more advantage is when the layers are built, we are filling the powder, the material powder, to the total build volume. So already there will be a support material. So we similar to where we are making in FDM or SLA 3D printing, there will be no support structure is required in SLS 3D printing. Currently there are the SLS 3D printing is used in industrial. There are some small scale SLS 3D printer, but it is not popular as FDM or SLA 3D printers. Next technology is material jetting. This is similar to a normal inkjet 3D printer. In normal printers, a paper will be in the bottom side, and ink cartridge will be there, and ink nozzles will be there. The ink nozzle will go over the paper, and it will deposit printing ink on the paper. Similarly, here the printer will use UV curable ink, and the printer head will move on the build surface, and the printer nozzle will deposit printing ink, and then a UV light will pass through. The UV light will also attached on the head, then the layer will be cured, and then the 3D printing head will move over this, and again it will deposit material, deposit ink or material, and then it will be shown to UV light, it will be cured. So similarly the material jetting 3D printer will deposit ink, UV curable ink, and it will be cured layer. The UV light will cure the ink which is deposited, and layer by layer the 3D object is made. One of the advantage of this material jetting 3D printer is it offers very high dimensional accuracy and very smooth surface. It has an inherent advantage of making multicolor. Material jetting is material jetting materials are photosensitive and their mechanical properties will degrade over time. So, the objects made using material jetting cannot be used for a prolonged time, or which this cannot be used for some dynamic applications. It also has high cost of printing. The material jetting 3D printer comes at a very high cost, and the material also is at high cost. Next is laminated object manufacturing. Here in laminated object manufacturing, in FDM 3D printer, the material will be comes as a filament, and it is heated and deposited on a plate. In SLA 3D printing, there will be a resin. The resin will be selectively cured to make the final object. In SLS 3D printing, the powder will be there, and a laser, using a laser beam, the powder is sintered to make the object. In material jetting, the UV light curable material is deposited through micro orifices, and it is cured using a UV light. Here in this case, in laminated object manufacturing, made using layer by layer of thin sheet of some material roll. This can be paper or can be plastic. Here you can see there are two rolls. One is foil supply, and the roll in the right side is the waste collection, and there is a heated roll. You can see it will move from left side to right side, and the build plate will move down once a layer is completed. In the top there is a laser source and a mechanism for pointing the laser beam in the XY axis of the build plate. So, initially the build plate will be at the topmost position, and over that the foil will be there, and the heated roller will roll over the foil, and then the laser beam will cut the layer according to the file given to the 3D printer. Then the laminated object manufacturing, the multiple layers are glued together. If the foil is if the material using is a paper, or it will be glued using heat if that is a polymer. And one of the main advantage of laminated object manufacturing compared to the other types are, this is having the object will be having very low cost, and the printing will be very faster compared to others. And this laminated object manufacturing also is not popular since it is not very precise, and support material removal is very critical, and this may damage the 3D printed object we require. In the material jetting, there is a combination of material jetting and selective laser sintering. That means Instead of giving a laser pointer to heat the material, make micro droplets of glue and it will be dispensed to the material. So, instead of the laser pointer in SLS 3D printer, the 3D printer will use a glue to bind material together, that is called a similar technology as the material jetting.